Assalamu alaikum. My name is Mishal Fatima and my registration number is 23 TE-55. Today I am going to present the topic of knowledge and inference in artificial intelligence. Artificial intelligence systems need knowledge to make decisions. They must be able to store information and use that information to reach conclusions. This process is called knowledge representation and inference. So let's start with logical agents. A logical agent is an AI agent that uses facts and logical rules to make decisions. It has two main components. The first one is knowledge base, which stores facts and rules, and the second component is inference engine, which uses those facts and rules to drive new conclusion. For example, suppose the knowledge base contains the fact Ali is a student and the rule every student studies. The logical agent can conclude that Ali studies. The working principle is very simple. The agent receives information from environment, stores it in the knowledge base, reason about it, and then performs an action. Logical agents are widely used in expert systems, medical diagnosis systems, and chatbots and robots. Now let's move to the propositional logic resolution. In propositional logic, statements can only be either true or false. For example, we have P. It's raining. Q. The road is wet. A rule can be written as if it's rain, then the roads becomes wet. Resolution is an inference technique used to determine whether a conclusion logically follows the given statements. The resolution rule says that if we have P or Q and not P or R, then we can drive Q or R. Let's look at an example. Suppose we have it is raining or the road is wet, and it is not raining or traffic is low. After applying resolution, we get the road is wet or traffic is slow. Resolution is commonly used in automated theorem proving, logic programming, and AI reasoning system. So now let's discuss forward chaining. Forward chaining is a data-driven inference method. It starts with known facts and applies rules repeatedly until a goal is reached. For example, fact is it is raining. Rule number 1. If it is raining, then the road is wet. Rule number 2. If the road is wet, then traffic is low. First, from the fact that it is raining, we conclude that road is wet. Then because the road is wet, we conclude that traffic is low. So we started from facts and eventually reached the goal. Therefore, forward change follows this flow: facts to rules, rules to new facts, and then goals. It is commonly used in expert system, medical diagnosis, and decision support systems. Next is backward chaining. Backward chaining is a goal-driven inference method. Instead of start with facts, it starts with the goals and works backward to find the facts needed to prove that goal. For example, suppose our goal is traffic slow, we look for a rule that can prove this. Road wet, traffic slow. Now we need to prove that the road is wet. Then we found another rule: raining, road wet. Now we need to prove that it is raining. If the fact it is raining, this is a fact, is already known, then we can prove that the road is wet and finally prove that traffic is low. So backward chaining follow this: goal to required facts and required facts to available facts. The main difference between forward and backward chaining is that forward chaining starts from facts and move toward the goal, while backward chaining starts from the goal and works backward toward the facts. Now let's move to the first order logic, also known as FOL. First order logic is more advanced form of propositional logic. It allows us to represent objects, properties, and relationships. There are four main components of first order logic. The first component is constants. Constant represents specific objects such as Ali or Lahore. The second component is variable. Variable represents unknown objects such as X and Y. The third component is predicates. Predicates describe properties or relationships. For example, student, his name is Ali. What do I like? He likes cricket. The fourth component is quantifiers. There are two types of quantifiers. The first is universal quantifier, represented by symbol like all, which means for all. For example, every X, if X is a student, then X studies. This means that every student studies. The second is existential quantifier, represented by symbol exist. There exist. For example, there exists at least one student. Let's see an example. Facts: students Ali rules every student study. From this we can infer Ali studies. Finally, let's discuss inference in first order logic. Inference means deriving new knowledge from existing facts and rules. For example, fact: Ali is human. Root: every human is mortal. Conclusion: Ali is mortal. There are several important inference techniques. The first is modus ponens. If P implies Q and P is true and Q must also be true. For example, if Ali is a student, then Ali studies. Ali is a student, therefore Ali studies. The second technique is universal instantations. In this method, a general rule is applied to specific object. For example, all humans are mortal. And the third technique is resolution. Okay, now in conclusion, local agents, resolution, forward chaining, backward chaining, first order logic, and inference and first order logics are fundamental concepts of artificial intelligence. These concepts help the AI system represent knowledge, perform reasoning, and make intelligent decisions. Thank you.